Hello, guys. Good evening. Sorry, good morning. Welcome to the session today. Hope you all are doing good. So, let us start the session. So, yesterday I have just given you some idea about what is data engineering, and after that, what is Google Cloud Platform, and few basic concepts that we have seen yesterday. So, that was an introductory session. Today, we're going to start with. So, as I told you, in a GCP overview, we are going to start with why we need a cloud. Okay, so why the cloud platforms came into the picture, and after that we will see what is the difference between the on-premises versus cloud, and what is Google Cloud Platform, introduction, learning, opportunities. All of these things one by one we are going to learn from today onwards. Okay, so let me start with the very first topic, that is cloud overview, and in that we are going to see why we need a cloud. Okay, so let us start with that one. So these are the topics that we are going to cover in our session. So let's see why we need a cloud platforms. Hope you all can hear me. If you are unable to hear me, please let me know in the chat. Okay. So for example, how an organization will work, how the requirement come into the picture, let us try to see. And how, for example, if you wanted to understand a end-to-end project flow, let us try to understand first, then we will go to the requirement. Okay, for example, assume that, let's consider if an organization wanted to roll out a new application. Okay, they wanted to create a new application, or they wanted to roll out a new application. The business comes up with the requirements for the application, right? The business comes up with a requirement for the application, and the business analyst will gather the needs from the business and analyzes it and converts it into a set of high level technical requirements. What the business will do, the business comes up with the requirements for the application. So for example, the organization wanted to roll out a new application, the business come up with a requirement for the application, the business analyst gather the needs from the business and analyzes it and converts it into a set of high level technical requirements. Then he passes that information to the solution architect. So he passes whatever the analysis that he has done, right? He passes that information to the solution architect. Now, the solution architect design the architecture to be followed for the deployment of this application. And then it typically includes the infrastructure such as the type or count of servers needed for the front-end web servers or the back-end web servers or databases and load balancers. So what the solution architect will do? Solution architect will actually design the architecture to be followed for the deployment of this new application. Whatever the application that we wanted to create, right? For that one, here he is going to create an architecture to be followed for the deployment of this application. And for this one, it may need, or it may include the infrastructure or a type of servers, the count of servers required, or the front end web server, or the back end databases, or the load balancers, whatever, right? So all of those things he is going to be creating a, with the help of all of these things, he is going to be creating one architecture to be followed for this deployment of this new application. Okay, then what will happen in the traditional model, right? So whatever the required data, whatever the infrastructure required, right? So that infrastructure, if it is directly available in the data center, there is no problem. Okay, so if all of those servers or the infrastructure or the web servers or the databases or the load balancers, so all of those things has to be available. If that is already available in the data center, if it is already available in the data center, there's no problem. There's no problem. Then what the application developers will do, they will try to deploy the application on top of this data center infrastructure only. Okay, this would have been deployed in the organization's on-premises environment which would mean making use of the assets in the data center only. If the additional hardware is required, see, if the additional hardware is required for rolling out this new application, they would have to order via procurement team. So they have to order via procurement team. This team will put in a request to the vendors. The procurement team, what it will do, it will try to create a request to the vendors. Now it will take a days or a weeks, even months for the hardware to be purchased and delivered to the data centers. Once it is received at the data centers, okay, what will happen, sir? So the solution architect will create the architecture to be followed for the deployment of the application. So when the architecture is created, inside the architecture, it will employ or it will include the infrastructure required for this rollout of new application. The infrastructure may be a type of server or the count of servers or a front end, back end databases, all of those things. So if those all are the hardware already available in the data center, there is no problem. Okay, because it is in an on-premises model, we are going to deploy everything on top of the owns on top of companies organizations data center only. If it is already available, there is no problem. But if the additional hardware is needed, they have to order it via procurement team. The procurement team will create a request to the vendors. Now it's going to be taking a weeks or a months or a years to be hardware to be purchased as well as delivered to the data center. Once that hardware is received at the data center, field engineers will come into the picture and they are the in charge for the rack and stack equipment. So they will create a rack and stack. They're going to be taking care of the rack and stack. And then the system admins will come into the picture and they will try to do the initial configuration of the systems. Okay, system admin, what they do, sir? System admin will do the initial configuration of the systems. And the network admin, what they will do? The network admins make the system to be available over the network. System admins will take care of the configurations, initial configurations. Network admin make sure that all of these systems to be available over the network. So that storage admins will come into the picture. They will take care of or they will assign the storage to the servers. Backup admin will come into the picture and take care of the backup. And finally, once everything is ready over the network, application team will try to deploy the application on top of this hardware or infrastructure. Okay, so what they are trying to do, once the procurement team has created a request to the vendors, it takes some time, and after some time the hardware will be purchased by the vendor and hardware will be delivered to the data center. Once the hardware is received at the data center, field engineers will try to take care of the rack and stack. System admin will do the initial configuration of the system. Network admin will make sure this all of these systems are available over the network, and storage admins assigns the storage to the servers. Backup admin will configure the backup. And finally, once the system has been set up as per the standard, then it will be handed over to the application team. Now the application team will deploy their application. This will be used for their new requirement. So as per the solution architect, whatever infrastructure is ready, and that should be ready in the data center. Once it is ready, all of these people are working behind the scene and the application team is deploying the application on top of the data center infrastructure. Then the new application is ready. That's how whatever the application nowadays we are using, right? A Flipkart or a Amazon or a Uber or a Swiggy, whatever you are using, right? So these many people are working behind the scene. Okay, these many people are working behind the scene. But there's a problem with this working model. This is what we call as the traditional working model, sir. This is what we call as the traditional working model. In a traditional working model, these many people are working behind the scene. Okay, these many people are working behind the scene. Now what is the problem with this one? Let us try to see. So there are many disadvantages where we can look at it here. So for example, if I wanted to create a new application, So I may have to wait a lot of time because these many people are working. So the turnover time varies from the weeks to months, everything to be ready for the app deployment. For example, even though the solution architect is creating an architecture, we are not directly deploying the application. We are waiting even days to weeks to months for the everything, the entire infrastructure or a hardware setup to be ready. So the turnover time is gonna be varies from the weeks to months to everything to be ready for the application deployment. So that is the reason it is called as a slow deployment model. The deployment model is very slow. And one more thing, if I wanted to scale it, if I wanted to scale up or if I wanted to scale down, that means if I wanted to increase my infrastructure or decrease my infrastructure as per the demand, it will not be achieved quickly. It will not be achieved quickly. Why? For example, if you wanted to increase the infrastructure, if that infrastructure is already available in the data center, that's fine. If it is not available in the data center, what we have to do, sir? We have to again create a request. The vendors again has to purchase the product and the vendors has to deliver it to the data center. Then the field engineer, system admin, storage admin, backup admin, then it will be deployed. So it's a scaling is very slow. That's limit. Okay, sorry. The scaling is not proper. Scaling will not be achieved properly. So scaling up and down as per the infrastructure demand cannot be achieved quickly. And one more thing, the overall cost to deploy and maintain this model is very high. Why, sir? For example, you see, for deploying one small application, also these many people has to work behind the scene, and we have to take care of all of these things. We have to take care of the data center, and the data center needs 24 by 7 electricity, 24 by 7 cooling, and we have to take care of the field engineers. We have to take care of all of these people working behind the scenes. So that is the reason the overall cost of deployment and maintaining this working model is very high. So that's the reason it is called as an expensive working model. Okay, it's called as an expensive working model. And you can see here some of the aspects we can able to automate it. But when you look at it here, most of the things like creating a request and waiting until the request is taken by the vendors, purchasing the things, making delivery to the data center, field and engineers, all of these things are cannot be automated because these are manual things cannot be automated. So that is the reason the automation is limited here. So field engineers, system configures, storage admins, backup admins, whatever the things they are doing it, right? It cannot be automated, right? Because the thing that they are doing is physical thing that it cannot be automated easily. So that's the reason it is called as a limited automation. Okay, so you can't automate the rack and stack cabling. Okay, so such kind of things cannot be automated. And one more thing, you can see here, due to many people are working behind the scene, there is a prone to a human error. With so many teams working on so many different tasks, the chances of human error is very high. Okay, it results into the inconsistency of the system, inconsistency of the environment. Okay, so if many people are working behind the scene and all of those things are manual things, if the so many teams working behind the scene on so many different tasks, there are chances of human error is very high, and it leads to the inconsistency environment. And another important thing is that the major disadvantage is that underutilization of the compute resources. So whatever the resources in the data center that you have, you may not be utilizing it 100%. Okay, you may not be utilizing it 100%. You may not be utilizing it properly. So that leads to the wasted resources. Okay, you may be using, for example, you need some 100 GB of the memory, but you bought like 500 GB. Okay, 400 GB, the rest of the 400 GB is wasted. So such kind of things going to happen. So wasted resources is one of the major disadvantages in the traditional working model. Due to these many disadvantages over the past decades, what are those disadvantages, sir? Slow deployment, the turnover time varies from the weeks to months to everything to be set up. The working model is very costly, and it is limited automation because only some of the aspects can only be automated, some of the aspects cannot be automated at all. And it is prone to the human error because many teams are working and there are chances of human error is very high. It leads to the inconsistency of the environment as well. And the major advantage is that the underutilization of the compute resources. So these many disadvantages, due to these many disadvantages over the past decades, organizations moving to the cloud platforms to take advantages of the services provided by the leading cloud providers, such as AWS, Azure, and Google Cloud Platform. Okay, with the help of these leading cloud providers, you don't need to worry about these things. You don't need to worry about these things. You don't need to take care of this field engineers. You don't need to take care of the system configurations. You don't need to take care of the storage admins. You don't need a backup admins. All of this, you don't need to maintain your own data center itself. Maintaining a data center, it's a very, very, very effort taking, time taking, and money taking process, guys. So you don't need to worry about all of these things. When you're working in an on-premises working model, you have to take care of all of these things. But when you're working in a cloud computing model, you don't need to worry about these things. Cloud provider will take care of all of these things. So that is the reason. So you don't need to worry about this procurement team as well. There is no kind of a team also. So what else happens in this computing model, cloud computing model is that, so whenever the business comes up with a requirement, business analyst will gather the information and he passes that information to the solution architect. The solution architect will create an architecture to be followed for the deployment of the application. Now there will be a DevOps team. Now there will be a DevOps team that will be replaced by all of these things. The DevOps team will create the infrastructure by using the cloud. Okay, the DevOps team will create the infrastructure by using the cloud services, and then within 1 or 2 days, the entire setup will be ready. And after that, application team will directly deploy their application on top of this infrastructure on the cloud. So now the application deployment will be happening over cloud, sir. It will not be happening on the data center. Okay, so this is what happening in the cloud computing model. When you're working in a cloud computing model, you don't need to take care of anything such as the field engineers, system admins, backup admins. All the things will be taken care by the cloud provider itself. We just have to select what resources, or we just have to rent those resources required for our deployment of the application. Then we can deploy it. The very next second the applications will be ready, we can deploy our the very next second is itself the infrastructure is ready, we can deploy our application on top of the cloud. This is the reason the deployment is slow deployment, and it is not cost effective. It is cost effective because you don't need to take care of the data center field engineers, you don't need to feed them, you don't need to provide salaries, you don't need to take care of the 24/7 electricity, water supply, all of those things you don't need to take care of it. So that's the reason it is a cost effective model. And in a cloud, all the things are going to be taken care with the help of the APIs, application programming interfaces. So when you're dealing with the APIs, the automation is very high. You can automate almost all the things. And there are no teams such as field engineers, system backup admins, storage admins. All of these teams are not there. So that's the reason the humans are very less. So there are very less teams working behind the scene. So the chances of human error is very less. That does not lead to any inconsistency of the system. The system will be consistent. And Whatever the resources we required, we only be allocating those resources. We are not allocating more or we are not allocating less. And there is always a auto scaling options are also there. So there is no wasted resources when you're working in the cloud. So this is how the cloud working model gives you the benefit of faster deployments, cost effective, automation is high, less human error, wasted resources are also less. There is no wasted resources at all. So this is how the cloud provider working behind the scene. Hope you got some idea now. So now let us enter into that's the main agenda, that why we need a cloud, guys. So when you're working in a cloud platform, you have a plenty of the disadvantages. When you're working in a cloud platforms, you got a very, I mean, you got the automation high, you got the deployment faster, you got the cost effective model, you got the auto scaling features, you got the you are not wasting the resources at all, and you don't need to, I mean, it does not lead to the inconsistency of the system, because it is almost less human error. So that is also there. So these many problems were solved, and that is the reason most of the companies are looking towards the cloud platforms. And the cloud platforms are also be nowadays very important. Each and every project nowadays working in the cloud only. Okay, then let us see what is the cloud platform, the difference between the on-premises and cloud computing model. In one sentence, I'm going to tell you. In on-premises working model, the organization managing its own infrastructure to run their code and applications, right? If one organization is there, if that is managing its own infrastructure or a own data center to run their code or applications, that is nothing but an on-premises working model or a traditional working model. In a, what is meant by infrastructure, sir? It can be a server, it can be a hardware, it can be a software or a networking or a storage. Okay, infrastructure can be any of these things. And what about the cloud computing model? In a cloud computing model, a cloud provider delivers the infrastructure as a service. Infrastructure, he will be delivering the infrastructure as a service to you. You are going to use that infrastructure for some amount of time, and you are going to pay for it. So pay as you go model. So this is the difference. The main difference between the on-premises and cloud computing model is that in on-premises, organization will make sure our organization will manage entire data center. In cloud computing model, you don't need to, an organization don't need to maintain the data center, because the cloud computing model can provide you the infrastructure as a service to you. You can make use of those services. Okay, so this is the main difference between the on-prem as well as the cloud computing model. Okay, this chart will give you a very good idea, guys. Look at it here. So this is cloud. Okay, because as I told you, on premises we have to maintain everything. Organization have to maintain everything. In a cloud, the cloud provider will deliver the infrastructure. How much infrastructure they will deliver? That's a question, right? So that we will see now. So in an on-premises versus cloud, look at this picture. This picture actually gives you a very good information. Focus on this point. You're going to understand everything from this picture only. Look at it here. When you're working in an on-premises working model, you have to physically buy the physically buy the hardware. As I told you, when you're working in a traditional working model, you have to physically purchase the infrastructure that is required for the application deployment. Then once the physical infrastructure is managed or purchased or whatever it is happened, then you have to take care of the virtual machines. Virtual machines, we will see, sir. Virtual machines is nothing but virtually existed machines. We cannot see those are not physical machines. So for your virtualization concept, we will see in our upcoming sessions. A virtual machine is like, for example, if you wanted to create if you wanted to work with a cluster, and if you wanted to have a three machines in the single machine itself, you can create a three machines with the help of the virtualization concept. So that we will see. So managing the virtual machines also you have to take care. Managing that means installing the application, installing the software. For example, you are developing a Python software, Python application. So you have to install the Python software. Then you have to take care of the dependencies of the Python software. You have to take care of the platform for the Python software. Then you can develop the solution. You can develop your Python application. One application, if you wanted to develop, right, you can develop it. Then you can go for the deployment. Okay. In an on-premises working model, you have to take care of buying your physical infrastructure and managing it, taking care of the virtual machines, managing the application service, developing the solution on top of this service. So all the four things you have to take care of it here. But when you go to the cloud, as I told you, as cloud provides you the infrastructure as a service, how much infrastructure do you want? How much infrastructure you are expecting from the cloud provider? So based on that, it is categorized into three. One is virtual machine based services, managed services, serverless services. Okay, so in a virtual machine based services, sir, in on premises I am buying my own machine, it is taking a lot of time for me. Sometimes the machines are not available, sometimes the hardware what I am going to purchase is taking a lot of time. I may have to move to another city and buy it, so it is taking a lot of time for me. In such scenarios, you can opt for the VM based services in the cloud. What it will tell is that you don't need to create or buy a physical machine. The physical machine will be provided by the cloud provider itself. The physical machine will be provided by the cloud provider itself as a virtual machine. So on top of the virtual machine, whatever the thing that you wanted to do, you can do. So all other things, but you have to take care of it. Installing the application, developing the solution, all other things you have to take care of it. So the first advantage with the VM-based service is that you don't need to physically manage the infrastructure here. That physical infrastructure will be taken care by the cloud provider. All other things like virtual machines, installing the applications or maintaining the application service and developing your solution, you have to take care of it here. So with the help of the VM-based services, one of the important aspect is managed by the cloud provider itself. So that's the reason we are only taking care of three. Okay. And next thing, sir, I don't want it to manage the physical infrastructure. Sir, I want the cloud provider to be take care of the virtual machines as well. Then I will just focus on this managing the application and developing the solution. So that is what you are going to just focus on the two aspects, where some of the services like data proc, where you don't need to worry about the physically buying the machines, you don't need to worry about the maintaining the virtual machines. Both of the things are taken care by the cloud provider itself. The very best example for it is cloud data proc, where you just have to provide the configuration. Once you provide the configuration, everything is ready. Okay, the virtual machines are ready. The physical machines are also ready behind the scene. You just have to install or you just have to configure what of the softwares if you wanted to install it. And then you can develop your solution. Like you wanted to do the PySpark development or the SQL development, whatever the application you wanted to define, or if you have a data, you wanted to process it properly. So you can go for this one. So then you are just taking care of the two things only. Sir, no, 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 no. I don't want it to focus on any of the infrastructure related things. I don't want it to take care of this thing, this thing, this thing also. I just wanted to focus on the development only. We are just developers only. We don't want to focus on any of the infrastructure related things. We wanted to just focus on the development only. That leads to the serverless platform, serverless services. So VM-based services, managed services, serverless services. In a serverless services, you as a developer doesn't focus on any of the management details for the infrastructure or a virtual machines or application service. You will be just focusing on the development. You will be just focusing on the development. Okay, so that is that you are just focusing only on the one thing here. See, when you're working from the on-premises working model to the cloud serverless, the amount of effort that is needed from you is lesser. And the other hand, I can also that the flexibility to work with the system is also higher. So for example, the flexibility is very high here. When you are working in a on-premises working model, the flexibility of working with the service is very high. So you can work with any of these things. The control is very high. But when you are working in the serverless, the control is very less. It's that you have selected it. Okay, so this is the reason most of the companies, they don't want it to buy their infrastructure, they don't want it to manage their data center at all. So entire thing will be managed by the cloud provider itself. So this picture gives you some idea, right? So how the on-premises working model works in a cloud, how these three models are working: VM-based services, managed services, serverless. VM-based services best example is compute engines. Managed services best example is Dataproc. Serverless services best example is BigQuery. Okay, in BigQuery, you don't actually worry about anything. You just create your data set, you just create your tables. That's it. You start doing the development. You are creating a data set means you started doing the development only. You have not worried about whether the cluster is available or whether the machine is available or whether the SQL editor is installed or not, whether everything is installed or not. You have not worried at all. You're just focusing on the development only. You are not worried about anything. So that's how the serverless services are working. These are very famous nowadays. Okay. So this thing gives you some idea, guys. So this is the difference between the on-premises working model versus cloud computing working model. So let's not look at it this thing now. Later I will tell you. Now go as I told you, Google Cloud Platform is providing you these many services. And we already seen what is a Google Cloud Platform. So one more time, I will try to explain it, guys. Google Cloud Platform is nothing but a cloud computing. If I have to say, it is a suite of services provided by the Google. So it is a cloud computing model. For example, if you wanted to work with a cloud computing model, Google Cloud Platform provides you the services or the products that if you wanted to build your application, or if you wanted to deploy your application, or if you wanted to scale your application, all of the services required for these activities are available in the Google Cloud Platform itself. So it's going to be providing you the suite of services. Okay, it's going to be providing you the suite of services like compute, identity and security, networking services, big data services, storage and database services, and machine learning services. Okay, all of these services are provided by the Google Cloud Platform only. And this is just a category. And inside that you see here, each and every service you can able to. Everything is a service, guys. Okay, so we are going to focus on the big data and storage and databases because we are becoming a data engineer only. This course is mainly for the data engineers as well as data admins, GCP admins. Okay, and why we need a cloud platform? We have seen why we need to learn the Google Cloud Platform, because Google has its own community support. We have been using the Google products from the last decade, and it has a very good community support. The services that the Google Cloud Platform providing you are the cost effective. When you compare the service cost for the same service cost in the GCP, AWS, and Azure, the GCP provides you the cost effective services. Okay, so for the same service in the GCP, it is like $60. It could be like $75 in the Azure, and it is like $90 in the AWS. It is in the Azure, it is in the AWS, but it is only $60 in the GCP. Okay, so and GCP also provides you 2 years organization support also. So that is the reason most of the companies are looking towards the Google Cloud Platform, because the services are cost effective and the reliability of the services are also there. Services are flexible, scaling up and down, reliable services, trustworthy, and these services are also secure compared to the Azure and AWS. And it provides you the fully managed services as well as serverless services. The interface for the Google Cloud Platform and the services are also very fast. The interface is also very easy to use. Okay, so this is the reason we are learning the GCP, and it's not that we are just learning the GCP, it's that the companies are looking towards the Google Cloud Platform. So that's the reason there are plenty of opportunities, but the less manpower. So that is the main agenda for us to learn the Google Cloud Platform. Okay, and it's a market leader. Industry adaptation, as I told you, from the startup companies to the big MNC companies, most of the companies are looking towards the Google Cloud Platform only. From startups to the enterprises are adapting the GCP for their cloud infrastructure, making the GCP skills are highly valuable in the job market. And comprehensive service portfolio is also there, as we have seen. uh, Google Cloud Platform provides you a rich set of services, including the compute, database, storage, networking, big data, analytics, machine learning also, so that it enables for you to deploy and scale your applications in the Google Cloud Platform itself. And integration compatibility, very important. We can integrate with all other services in the GCP. So it produces seamless integration. For example, sir, I wanted to use GS with a BigQuery. You can easily integrate it as much time. Okay. So whenever you wanted to establish an integration between the services, it's very easy and it is compatible as well. Okay, and one more thing is that the Google Cloud Platform also provides you the machine learning capabilities, which is very important for nowadays. The machine learning services like TensorFlow, AutoML, AI platform allows you to deploy the intelligent applications as well. And Google Cloud Platform infrastructure is available throughout the world, so you don't need to worry about, sir, is the data center is near to me or is the data center is very far to me? Because if the data center is very far to me, the applications is deployed on the data center used by the many users. The application will be delay, or the application may be lag, or the latency will be there. So such kind of a problems will not be there at all, because Google infrastructure is available in throughout all the world. And in India also we have two data centers in Mumbai as well as Delhi. So whenever someone wanted to deploy the applications in the Google Cloud Platform, they're actually deploying the infrastructure near to them. So they're actually deploying the application in the Delhi or Mumbai only. Okay, so multi-cloud projects. So the multi-cloud projects era also came into the picture nowadays. Some of the companies are using the multiple clouds. For example, so one project, they are actually using three clouds at all. Three clouds, Azure, AWS, and GCP also. Some two are the services from the GCP, two of the services from the AWS, two of the services. This is called the multi-cloud projects. Okay, multiple cloud platforms are they are using. So this is also one more important aspect. And certification and career growth also there. So for example, GCP certifications validate your knowledge and expertise, and if you wanted, it also increase your career opportunities and the earning potential in the cloud industry. So this is the reason also we should learn the GCP and make certified in the GCP. Okay, and growth market, you can also see here in the last quarter, 50% of the growth market is there for the GCP. That means most of the companies have started using the GCP because of its cost effectiveness. And the roles offered with this particular course, you can go for the GCP data engineer, you can go for the GCP developer, you can go as a GCP admin also. Okay, by completing this course, you can go as a GCP data engineer, you can go as a GCP developer, GCP admin also. And the certifications, once after completing this particular course, you can attempt for the associate cloud engineer as well as a professional data engineer. Okay, so with this one, I'm going to stop here the session today. I just wanted to take 15 minutes, just 10 minutes to tell you how to interact with the GCP, and I'm going to stop it here. Okay. So as I told you, Google Cloud Platform is providing you the many services like compute services, big data services, storage and database services. But how to interact with these services, sir? So if you wanted to interact with the services, you need to have a medium. You need to have a medium to interact with these services. So can you tell me what are the ways to interact with the services? So if you wanted to interact with these services, we have four methods. One is console. The second one is Cloud Shell. The third one is APIs and client libraries. The fourth one is web applications. Web services are applications. Okay, so when someone wanted to, when someone or when some application wanted to interact with the Google Cloud Platform, there are actually four ways to interact with the GCP services. How many ways, sir? Four ways to interact with the GCP services. One is via Cloud Console. The one more is Cloud Shell. The third one is Cloud APIs or the client libraries. The fourth one is web services or applications. Okay. So what is console, sir? Let me gonna open the console and I'll show you. Why did it not stop it? Let me refresh it once. So if one wanted to use the GCP, right? I'm going to tell you how to create an account. Don't worry. I will tell you how to create a free account. You all can create a free account. Maybe I'll tell you tomorrow. Okay. So you can go to console.cloud.google.com. console.cloud.google.com. If you go to console.cloud.google.com, so this is the page opens. Okay, this is the page opens. So this is what we call as a console only, sir. This is what we call as a console. What is a console, sir? A console is a web-based user interface tool. Web-based graphical user interface tool. That means if you wanted to interact with any of the service in the GCP, you are going to use the user interface only, visual user interface. That means, sir, for example, I wanted to work with the BigQuery. So you come here, you search for the BigQuery and you click on it. See what you are doing? Everything you are doing via visual interface only, right? So you wanted to create a one more table, you come here and create a table. So in Google Cloud Platform, if you wanted to interact with any of the service in the GCP, there are actually four ways. One of the first way is console. Console is nothing but a user interface. If you wanted to work with the cloud storage, you click on it. If you wanted to work with the BigQuery, you click on it. Kubernetes engine, compute engine, IAM and admin. So you are going to use the visual interface to interact with this GCP services. That is called as a console. Console is nothing but a web-based visual user interface. Okay, so anything can be done here. If you wanted to create a bucket, delete a bucket, create a table, delete a table, create a compute engine instance, delete a compute engine instance, providing the services, access to the multiple users, providing a project access to the multiple users, everything we are going to use, everything we can do it with the help of the console also. So this is called as a cloud console, sir. What is this one? This is called as a cloud console, where it is a visual user interface. Okay, so that is web-based graphical user interface tool. GUI, nothing but a graphical user interface. So if something we are doing it via visual user interface or a graphical user interface, we actually call it as a manual thing. We actually call it as a manual thing, right? So everything we are going to do it with the help of the manual clicks only. But what is the other way? You can also interact with the GCP services via command line interface. Okay, you can also interact with the GCP services with the help of the commands, with the help of the scripts, with the help of the shell scripts or a commands or a code. If you wanted to interact with uh, Google Cloud Platform services via command line interface, then you have a Cloud Shell. What is this Cloud Shell, sir? Cloud Shell is a web-based Cloud Shell is a web-based command line interface. It is a web-based command line interface. Where is that, sir? So this is console. It is also web-based, right? So command line interface also web-based. You see here at the top you have a activate Cloud Shell. Click on that. When you click on it, bottom side you will be opening some Cloud Shell terminal. So you are going to interact with the GCP services via commands here. So it is a command line interface, web-based command line interface. You see here. So if you wanted to work with the BigQuery, you so use BQLS. BQLS. Okay, BQ means BigQuery LS. So each service will have its own commands. You see here dataset ID. We have only one dataset. If you go to the BigQuery, so you can do two things, right? So for example, sir, I wanted to list out all the data sets in the BigQuery. So via command also I can do. If I go to the BigQuery, okay, I can go to the BigQuery and click on it here. See here, I have only one data set. The data set name is sample DB. And here also I have seen. So whatever the activity that you are doing or whatever the interaction that you are doing with the GCP services can be done via console as well as Cloud Shell. Okay, so that is what, sir. Inside the BQ sample database, I wanted to list out. See, inside the data set, I have three tables. If you wanted to see the same thing, BQLS sample DB. See here, I can also see the three tables here. Also, employee table, test one, test two tables. You can also see employee table, test one, test two. So whatever the interaction that you can do from the console can also be done via Cloud Shell. Console is what, sir? It is what we are doing here. So if you wanted to see, just click on it here. This is a user interface. What is this one? This is a command we have written. So BQLS sample lib is a command that we have written. So we are going to learn both of all of these things in our upcoming sessions, where we are going to interact with the services via console. We are going to interact with the services via Cloud Shell as well. So as a developers, we must focus on these two. As a developers, we must learn these two very good. Okay. And the next thing is APIs and client libraries. APIs for the automation. APIs is to automate the things. Client libraries. So it is a web-based SDK, a web-based CLI, right? So client libraries is called as a software development kit. It is a local software development kit. It is not. It is also a similar to the CLI. So software development kit or CLI, both are same. It is also a command line interface only. Okay, but this one was web-based, but this one is local. You can install it, you can download it and install it. I will show you in our upcoming sessions how we can able to install it. For me, it is already installed. I will show you. For me, it is already installed. If I click on it here, SDK, see here, Google Cloud SDK shell. You can click on it and it opens. So it opened like this. Okay, so this is also SDK. It is installed on my local machine. Okay, it is installed on my local machine. So this is web-based shell. This is local shell. So web-based shell is nothing but a Cloud Shell terminal, and this is our SDK shell, software development kit. It is a Python software development kit, so it is called as a SDK, software development kit. So this is also called as a client library. So you can see here, if you wanted to interact with, first I need to connect it to the particular account, right? Cloud auth login. I'm going to log in into my Google Cloud account first. Okay, it's not connecting. That's okay, it's connecting. Yes. Click select that account. Allow. Once it is allowed, right, you are going to see here. So you can see you are now logged in as this particular account. I have created my account. I have logged into it. So you can see here now you can select BQLS. See here sample DB. BQLS sample DB. You can also interact from here also. Okay, the name is okay. Sorry, sample DB name is wrong. BQLS sample D is capital, sir. See here, these many tables are there. Okay, this is a one more project, sir. This was one more project, so that's the reason it was showing differently. So this is the GCP morning batch project. You can also select that project. So for example, if you wanted to select this project, okay, you can see if you wanted to select a project, different project in the console, you will just click on it. You will select the whatever the project you wanted to. But in the Cloud Shell or a Cloud SDK, what you have to do? You can select gcloud config that project. You can select a different project here like this and provide the project ID. So this is how you have to do. Okay, so that's how the project ID will be changed. Here also the same thing. If you wanted to set the project, gcloud config set project ID. Project ID is there. So BQLS sample DB. If you give earlier, we have only 3 tables, right? You will get it. That is a different project. Okay, each service is different when it is worked in a different project. Okay, only tables. In that particular project, when it was a BigQuery, it has this many tables. In this particular project, in the BigQuery, we have only 3 tables. Each project is different. Each services are working under the project only. Okay, so this is how you can able to interact with the services from the client libraries as well. Final thing is web applications as well as web services or applications. So when one web service wanted to interact with the GCP, it can also be interacted, and when application wanted to interact with the GCP, can also be interacted via APIs. So that is there. So this is not, as a developer, we are not doing it. If one application wanted to interact it, for example, one application backend can be there in the GCP's database. So that is the reason. So that can also be interacted. Our main agenda is to learn about console, shell, and client libraries. Okay, what is console? A console is a web-based user interface provided by the Google. It allows you to manage and configure the GCP resources visually. So if you wanted to create virtual machines, managing the storage, configuring the network, monitoring your resources, all you are going to do it via visual interface only. This is GCP resources, you are going to manage it visually. Okay. And next thing, Cloud Shell. Cloud Shell is an interactive browser-based shell environment. Shell means command line interface environment. Okay, Cloud Shell is a command line interface environment available in the Google Cloud Platform. It comes up with a 5 GB storage, and you can able to store your files here. And it also comes up with the pre-installed popular programming languages as well. Okay, you can also see here, sir, if someone wanted to write code. So for example, sir, ls. So clear it out. So if you wanted to write Python, right? So Python 3. Okay, Python 3 hyphen version. Okay. See here, Python is pre-installed. A Cloud Shell, some of the popular programming languages are installed, pre-installed. Java, see, JDK 17.07, and Java Development Kit, people call it as, and Terraform. See here, Terraform v16, it's an updated version. So this is how Most of the programming languages comes up with this one, and it comes up with the 5 GB storage as well. You can also somewhere see it. Okay, later you can see it, guys. Okay, so it comes up with the 5 GB storage. You can store some data. So you can see here in my storage, I have like beam.y, color.txt. Some of the files also I have stored here. So you can store some code, you can store some files, you can store some repos, everything you can able to store it here, manage it here from here. You can write your code also here. Okay, yeah, that we will see in our Linux topic. We are going to learn about the Linux. Inside, when we are learning the Linux, right, all of the commands, whatever I'm telling now, right, ls command, all of these commands we are going to learn very detailed. So don't worry. So we have a Linux session, 1 or 2 sessions we are going to see. Okay, yeah. And so this is what Cloud Console and Cloud Shells are. Finally, a note. These are some common ways to interact with the GCP. The choice of method depends on your preference, requirements, and the type of interaction that you wanted to have with the GCP resources. Whether it's through a user interface or a command line interface or a APIs or integration with the third-party tools or an applications. So what this note says is that what we have seen 4 ways to interact with the GCP services, but which choice is preferred, sir? Which one is mostly used? It totally depends on your project requirement. It totally depends on the interaction that you wanted to have with the GCP service. Okay, so it totally depends on the interaction and totally depends on the requirement of the project. So some project says BigQuery can only be used in the Cloud Shell. Some project says BigQuery should be used in the Cloud Console. So it totally depends on it, and it also depends on the user. Some user wanted to use the commands more than the user interface. Okay, so this totally depends on the preference. Okay, yeah. So I'm going to stop the session here for today. And if anyone have any questions, please raise your hand. Tomorrow we are going to see the console walkthrough. I will give you tomorrow all the things. I will tell you about where is this one, what is that one. I will also tell you how to create a free tier account in the GCP. That will be very useful for you to practice also. And later we will start GCP locations. What is GCP locations? All of those things we will see. Okay, any questions? Any questions, anyone? Please raise your hand. Please raise your hand. Okay. Uh, yes, Satyadev. So the engineer is what the engineer will do. The engineer actually do the development, right? Architect will design the things. Correct. So the data engineer is the one who actually develop the things. Okay, who actually developed the code, who actually developed the code. But the architect is the one who is already skilled in development, and he also additionally have the things, the additionally have the skills of architecting the things as well. That means the architecture is a higher role where he already comes from the development side. So he already developed many things. With that experience, he can able to architect the things. So what he say, for example, he's for example, assume that I have some 1 terabyte of the data with me, and where I have to store it. So the data engineer may not be able to give a proper answer to that. But the architect will say from his experience, okay, if you go to store it in the Google Cloud Storage, the cost of the model is very less. And if you store it, the access control can also be done very easily. And if we store it, we can able to take care of the protecting the data also. So such a kind of a knowledge with the architect will have. The developer is someone who is actually taking care of the storage, who is actually uploading the file and storing it in the Google Cloud Storage. So that's the developer will do. This is the architect will do. Okay, designing the architecture or designing the deployment model to be followed will be explained by the architect, and actual things work will be done by the developer. That means the data engineer. Okay, yeah. Of course, data engineer or some Power BI engineer or some application engineer, whoever it is, they are actually the developers only. First thing, they are actually the developers only. They are actually developing something. It is for the application engineer, he will be doing the application development. Some Power BI engineer, he will be doing the Power BI development. So they are you already mentioned it as a testing, right? Why you are saying again a developer? They are admins. They are admins. They are not developers. So if they wanted to become, for example, one admin or one tester wanted to become, right? So they should learn the development skills, right? So for example, sir, I am a database admin. So I wanted to become a database developer, or I wanted to become a data engineer. That means I am going to become a developer. That means either you are going to learn the SQL for the development, SQL development, or a PySpark development, or a Beam development, or a DAG creation. So all of those things we are going to cover in our sessions so that they can become a data engineers. Okay, so that's what our entire course is focusing on. Okay. Okay. It's better for you to become a data engineer. Then after 1 or 2 years, you can go to the data. See, so in the ladder for you, you are already admin. You got many things, but you are lacking the development skills. So you, as an admin, you might have got many things related to the applications or related to the services. You got a good knowledge, but as per the development, you should also know. So that's the reason you should learn the development skills. Then in the next thing in the ladder, the next thing for you is an architect. Okay. Yeah. So all of these are interlinked. See, if a developer wanted to become a DevOps, he can also do that. See, there are many data engineers who become a DevOps engineer. There are many data engineers who become a machine learning engineer. There are many data engineers who become a data architects. There are many data engineers who become a solution architects. So it always depends on everything is interlinked. The only thing linked to is that they must be the developers first. Okay, a DevOps engineer, DevOps development plus operations, he might have already done the development. Now he wanted to go into the operations and make both. It's a principle that both the development plus operations he will be able to take care of it. And machine learning engineer, a data engineer can become a machine learning engineer or a data scientist because he already engineered the things. He already was an engineer. He already engineered many related activities related to the data, so he can again create a models. He can create a future trends as well. So that's where data engineer to the machine learning they can become. And a data engineer already the developer, he wanted to become a solution architect, then he can go again. So it again, there's a very path, guys. So in the ladder, if you wanted to become, no, sir, I don't wanted to be in the entire development field. I wanted to become a business. I wanted to go into the business field. Of course, you can become a business manager as well. Okay, with the development knowledge, because if you already know the development, you can go anywhere. Either you wanted to become an architect, or you wanted to become a machine learning, or you wanted to become a DevOps, or you wanted to become a business manager. So all in your hands, but it comes with an experience. Okay. Yeah. Yes, of course, you have to learn the development things. It happens, but I mean, a lot many years is going to take for you. For as a admin wanted to become a solution architect, it's not that easy. They may have to wait at least 15 years, 16 years. Okay, it's going to take a lot of time. But a developer, it becomes very easy for the developer. Okay, if a senior developer is there, he is working like 6 years, 7 years, he may become a data architect or a solution architect with the 8 years experience only. Okay, yeah. Okay, anyone have any other questions, guys?
Yes,
Yes, Yadagiri.
sir. We handle to duplicates and null values in SQL constraints topic and BigQuery how to
Wait a minute.
handle.
Wait a minute. Okay, Dharmendra, I have not. Dharmendra, I will ask you question. I will ask you. Yes, Adagiri, you are asking something.
Yes, sir. In SQL, we runtime we are doing constraints applying duplicate and null values. We handle to handle
We
the
will do that. We will do that.
yeah, yeah.
We will learn all of those things. Yes, of course.
Okay, okay, sir.
Yeah. Yeah, there is one guy asking Atul Singh, and what is the benefit of GCP when AWS and Azure are providing you the cloud platform since long time and have a huge market share? So it's like this. So, for example, if someone is providing, if you go to a supermarket and if you wanted to buy a chocolate, right, you will be having a varieties of brands. But if something with the very good quality and with very good taste and with the very cost effective, then you're gonna be buying it, right? So that's the main thing is happening nowadays. Google has been there from the last of 15 years, and most of the people are using the Google products, and they already know that the Google is a trustworthy. And one more thing, the Google is started providing you the services with the cost effective. That's where most of the companies are looking towards. So that is the reason when compared to the GCP, when compared to the GCP, AWS and Azure is already there in the market, but GCP is providing you the good services with a less cost. And not only that, you if you actually look at it, when it comes to the big data, most of the AWS and Azure projects are also migrated to the GCP. You do not know that with the community. I am also from the community member, so I could say this thing. GCP is very famous for the big data. Okay, very famous for the big data project. That means data engineering projects. GCP is very famous. It already took over the market from the AWS and Azure also. When it comes to the big data, when it comes to the machine learning, AWS is the market leader. When it comes to the big data, GCP is the market leader. When it comes to the CI/CD platform, Azure is the market leader. So each cloud platform has its own benefit. Okay, so that's the reason we have an era that is coming, that is multi-cloud projects. Okay, some of the services are very good in the some different cloud platforms. So the projects are the project leaders or the solution architect thought about it, and they are creating a project with the multiple services coming from the multiple cloud projects. So that is the reason you have to learn the GCP. And GCP is, again, most of the companies started using the GCP. Plenty of opportunities are there. Yes. Yes, Dharmendra. You don't need to install anything. I'm going to tell you how to create a free tier account in the GCP. Everything we are going to do in the GCP only. Yeah. Any other questions, anyone? Okay, guys, I think this is it for today. We will see and we will meet tomorrow at the same time, and we will see the rest of the things, and we will wind up tomorrow. Yep. Okay, guys. Thank you all. Have a great day.